Hi, Geometry. This is Unit 5, Lesson 12, page 599 of our workbooks. In this first activity, we're going to look more carefully at the surface areas between a pyramid, a prism, and also a cone. So notice it says to draw all the surfaces of each solid. That would be each face, each outside part of my three-dimensional shape. So let's take a look at A together. In this first one, I notice that my shape is sitting on a rectangular base going up to this point. So I know that this is a pyramid since it comes up to a point, and it's a rectangular pyramid since it's sitting on a rectangular base. So its surfaces are this rectangular base. So here's my base. And then I have 4 triangular sides. So if you think about it, my front triangle and my back triangle have this length from the rectangle. So I have my front triangle and my back triangle. You can see my front triangle in blue, and my back triangle is on the back edge, made up of those. So this is my front triangle and my back triangle. So then I also have 2 side triangles. Those are made up of this little width and this little width right here, and they also go up to the point. So you can see this one, for instance, on the right side. Sorry, my lines aren't very straight there. So I have my little skinnier side triangles. I have one on the left side, and I have one on the right side. So those are my side triangles, and these are my 5 faces, or my 5 sides of my rectangular pyramid. So why don't you take a chance and do B and C, stop this video, do B and C, and come back. I'll have my answer on screen as well, and we can see how we did. Welcome back, Geometry. So let's take a look at B. This was a triangular prism. Notice my 2 red triangular bases. And then notice that I have 3 rectangles. The one in the front that's been traced in yellow, and then 2 on the back side. Those are made up from the 3 sides, attaching the 3 sides of my triangular bases. So there's 5 surfaces, 5 faces total. So now let's take a look at our cone. Our cone in C has 2 parts to it. There is a circular base, and then wrapped around my circular base is a shape called a sector. In our Zoom, I will show you a cone I have, a paper cone that's deconstructed, so you can kind of see this in action. But this would be a sector. It's part of a circle. So let's add D here. Let me go back to blue. Let's add a cylinder, just to look at a cylinder real quick. So we'll add D. We'll add a cylinder to our diagrams. So remember our cylinders. Let's draw our 2 circles, and let's attach our sides. So this is my not as nicely drawn cylinder as yours. So a cylinder is like B. It's like our triangle prism. I have 2 circular bases. So I have 2 circular bases. So these are my circle bases, and there are 2 of them. So again, like the cone in our Zoom, I'm going to show you wrapped around the entire edge of my circle is actually a rectangle. So around the whole edge of both the top and the bottom base, I wrap this rectangle around, and this is actually the side of my cylinder. So this rectangle is the side of my cylinder. So let's take a look at the summary, if you would please. In the next lesson, in lesson 13, we are going to develop the formula for the volume of a pyramid. So prisms and pyramids. Looking at this diagram, they are physically showing you that 3 pyramids fit into this cube, 3 square pyramids. So this is my green square pyramid, and you can see him in the front of my cube. This is my first one. This is my second orange square pyramid, and you can see him in the back of my cube. And this is my third light blue or aqua pyramid, and you can see him in the back corner of my cube. These 3 come together to create my cube. And so one of the things we're going to learn in the next lesson is the volume of a prism. Actually, we already know this. The volume of a prism is my base, area of my base times my height. But for a pyramid, we're going to find that the volume is 1/3 times the base of the pyramid times the height. And you can see here how 3 pyramids fit into 1 prism of the same base. So notice that it has the same base area, and so 3 pyramids fit into this 1 cube. So something you could think about is if this cube had a base edge of 5, let's say, so 5 by 5 by 5, I know the cube's volume is big B times H, and big B is just a square. It's the length times width times height. And so 5 times 5 times 5, my volume would be 125 cubic units, or units cubed. So technically then, each of these pyramids would be whatever 125 divided by 3 is. This would be another 125 divided by 3. This would be another 125 divided by 3 in volume. When I add them together, I would get my total of 125 cubic units. These pyramids are 1/3 of the overall volume because it takes 3 of them to fill into my cube. And we'll be studying this more in the next lesson as well. So this is page 603 of your workbook. And number 3 deals with the idea of 3 pyramids being put together, assembled in such a way that they make a cube. So these 3 congruent square pyramids can be assembled into a cube, just like in the summary. It says that it has a side length of 1 foot. What's the volume of each pyramid? So you need to think about the cube that these 3 come together and assemble and make. This cube would be a 1 by 1 by 1 cube. Think about what the volume of my cube is. What does that mean for the volume of each one of my pyramids? This is the next page, page 604 in our workbooks. I want to talk about both 5 and 6 for just a moment. In number 5, I want you to notice what's missing is your H. You need to set up your entire volume formula like normal, except now I know the volume. It's 54 cubic units. I need to solve for H. So first of all, let's take a look at my problem. I have 2 triangular bases. Here's one, and there's the other one. So my volume formula for number 5 would be the area of the base times the height. Since it is a triangular prism, my base is a triangle. So I need to do 1/2 my triangle's base times my triangle's height. That's my big B right here, times then the height of my prism. So when I look at my triangle, I'm actually not given the base and the height. I'm given the hypotenuse and one of my legs. You can call it the base or the height, it doesn't really matter. So I would need to use my Pythagorean theorem to solve for CB, because my base and height have to be perpendicular to each other. So since it's 4, 5, if you use your Pythagorean theorem or if you use your Pythagorean triple, you know that BC is 3. So the two sides the two legs that are my base and height, they have to be perpendicular, are 3 and 4, not 4 and 5. So when I set up this formula and I substitute in my volume is 1/2 my base and my height, which is my 3 and my 4, not the 4 and the 5, not the hypotenuse. It doesn't matter what order you put them in, makes no difference. Times then the height of my whole pyramid. So I am now going to substitute in my 54 for my volume, and I'm going to use my algebra skills to now solve for my height. So that's on you. Let's take a look at number 6. It says this solid has curved sides. All cross sections are parallel to the base and they're squares measuring 3 by 3. So anywhere I cut this, my cross section is actually a square. So if you could imagine a deck of square cards, for instance, you line up the first card and you kind of come out with the second and come out and come out and come out. And then you get to a point where you're going to start curving back in as you're stacking these squares. And then the illusion or the figure, when you're done with it, looks like this curved figure that I didn't sketch very well. But that's what's happening with my my squares. So it wants you to find then the volume of this figure. So it says the height is 5 units. So from this top square down to this bottom square is 5 units. So think about your volume formula for a square prism and how you could find the volume with those dimensions. Thank you so much.